Bismillah ar-Rahman ar-Rahim. Day 10. The citric acid cycle. How we can extract energy from pyruvate. Welcome to day 10. Today we continue our metabolic journey by exploring the citric acid cycle. It is also known as the Krebs cycle or shortly TCA. The central hub of aerobic energy metabolism. Where does it happen? Citric acid cycle occurs in mitochondria. Where exactly in the mitochondria? In the matrix. The mitochondria represent the powerhouse of the cell. What are the starting point of the Krebs cycle? It is acetyl coenzyme that is produced from pyruvic acid, that produced from glycolysis, also from beta oxidations of fatty acid. Before entering the Krebs cycle, pyruvate, which produced from the glycolysis, is converted to acetyl-CoA through the enzyme pyruvate dehydrogenase complex. It will produce one NADH, release one CO2 per each molecule of pyruvate work on. Let's remember, from glycolysis we produce 2 pyruvate. So in this reaction, pyruvate will convert it to acetyl-CoA. An overview of the cycle. The citric acid cycle uses acetyl coenzyme, which is formed of a 2-carbon unit, and it combined with the prim of the Krebs cycle, which is oxaloacetate. Oxaloacetate is 4 carbon, so the formed molecule will be called citrate, which is formed from 6 carbon. The enzyme that stimulates these reactions will called citrate synthase. The enzyme that synthesizes this acid. It then goes through a series of 8 enzyme reactions, which through the cycle we release 2 CO2, produce 3 NADH, 1 FADH, 1 GTP or ATP per each cycle, and regenerating oxaloacetate to repeat the cycle. And that is why it is called cycle. Cycle, we start at a point, we make multiple steps, and we return to the start point. Okay, so we start with combining acetyl coenzyme with oxaloacetate. We go to this series to burn this acetyl-CoA and end the cycle by regenerating oxaloacetate that will be prim for a new cycle. Since each glucose yields 2 pyruvate, so we produce from this pyruvate 2 acetyl coenzyme. The cycle turns twice per each unit of glucose. Why it is important, this Krebs cycle? Number one, it generates high electron carrier, NADH and FADH, which will go to the electron transport chain and oxidative phosphorylation habit in electron transport chain to this electron carrier, producing large amount of ATP. Okay, why also this Krebs cycle is important? Number one, it provides energy. Number two, it provides intermediate molecule used for biosynthesis. Like, we can use the intermediate of Krebs cycle to synthesize amino acid. Like what? Like alpha ketoglutarate. We can use it to produce glutamic acid. Oxaloacetate, we can use it to form aspartic acid. Okay. Also, we can form lipid and heme. Heme, we produce it from succinic acid. Okay. Key enzymes to remember. These are the regulatory enzyme in this Krebs. These are the key enzyme. Number 1, citrate synthase, isocitrate dehydrogenase, alpha keto glutarate dehydrogenase. These are important regulatory points in the cycle. In summary, the citric acid cycle is metabolic engine of aerobic life. It is not about producing a lot of ATP directly. It only produces one ATP. But it's about creating a fuel which is NADH and FADH for the next change in electron transport change, where we oxidative these electron carrier NADH and FADH and use it to synthesize ATP in a process called oxidative phosphorylation on electron transport chain. Join us tomorrow for day 11, electron transport chain, making the most ATP. Thank you.